The 2026 USS Zumwalt DDG-1000 Destroyer represents one of the most advanced and futuristic warships ever built. Unlike traditional destroyers with their recognizable angular towers and exposed equipment, the Zumwalt immediately stands out with its sleek, stealth-inspired design that looks more like a vessel from a science fiction movie than a conventional naval warship. Every surface has been carefully engineered to reduce radar reflections, making the ship significantly harder to detect than previous generations of destroyers. Its unique tumble-home hull slopes inward as it rises above the waterline, creating an unmistakable silhouette while also contributing to its low radar signature. Although the Zumwalt class was originally planned as a much larger fleet, the three ships that were ultimately built have become technology demonstrators and highly capable platforms for next-generation naval warfare. By 2026, the USS Zumwalt continues to evolve with upgraded combat systems, expanded missile capabilities, and a growing role in modern naval operations. Powering this impressive warship is an integrated power system that remains one of the most revolutionary engineering achievements ever installed on a surface combatant. Instead of relying on separate systems for propulsion and onboard electricity, the Zumwalt generates electrical power that can be distributed wherever it is needed. This innovative approach allows the destroyer to operate powerful sensors, advanced electronics, and future energy weapons while maintaining exceptional efficiency. The propulsion system delivers smooth acceleration and impressive speed despite the ship's enormous displacement of more than 15,000 tons. Electric motors also produce less mechanical noise than traditional propulsion systems, helping reduce the vessel's acoustic signature beneath the ocean's surface. This quieter operation makes it more difficult for enemy submarines to detect and track the ship, providing another important tactical advantage. One of the most impressive aspects of the 2026 USS Zumwalt is its advanced stealth technology. Every detail of the vessel has been designed to minimize detection from enemy radar, infrared sensors, and acoustic tracking systems. Antennas, weapons, and other equipment are integrated into the ship's structure whenever possible instead of protruding outward like they do on conventional warships. Heat management systems reduce infrared emissions, while advanced coatings help absorb radar waves rather than reflecting them. The result is a destroyer that appears much smaller on radar screens than its actual size would suggest. This stealth capability allows the Zumwalt to operate closer to hostile coastlines, gather intelligence, and launch missions while remaining significantly harder to locate. The ship's combat system combines some of the most sophisticated sensors ever deployed at sea. Advanced radar arrays continuously monitor the surrounding environment, tracking aircraft, missiles, ships, and other threats simultaneously. High-speed computers process enormous amounts of information in real time, giving the crew an exceptionally detailed picture of the battlefield. Automated threat assessment systems help prioritize incoming dangers, allowing commanders to make informed decisions within seconds. The integrated combat management system connects every major sensor and weapon into a unified network, ensuring rapid responses during complex engagements. This level of situational awareness gives the Zumwalt a major advantage in both offensive and defensive operations. Missile capability remains one of the destroyer's greatest strengths. The ship features an array of advanced vertical launch cells positioned around its outer hull rather than concentrated in a single central location. This unique arrangement improves survivability because damage to one section is less likely to disable the entire missile inventory. Depending on mission requirements, the launch cells can carry a variety of weapons, including long-range land attack missiles, anti-ship missiles, anti-aircraft interceptors, and anti-submarine rockets. This flexibility allows the USS Zumwalt to adapt to multiple mission profiles ranging from coastal strike operations to fleet air defense and anti-submarine warfare. As new missile technologies continue to emerge, the ship's flexible launch architecture allows for future upgrades without requiring a complete redesign. Another remarkable feature of the Zumwalt is its advanced automation. Traditional destroyers of similar size often require crews of more than 300 sailors, but the USS Zumwalt operates with a significantly smaller complement thanks to highly automated engineering, damage control, and combat management systems. Sophisticated monitoring equipment continuously checks machinery performance, identifies maintenance requirements, and alerts the crew before problems become critical. Automated firefighting systems, remote-controlled equipment, and digital diagnostics reduce workload while improving operational efficiency. A smaller crew also means reduced operating costs and additional space for mission equipment, command facilities, or future technologies. Inside the ship, the technological sophistication continues. Crew accommodations have been designed with improved comfort compared to many older naval vessels, recognizing that modern sailors often spend extended periods at sea. Digital control stations replace many traditional mechanical systems, and touchscreen interfaces simplify ship management. Information can be shared instantly between departments, allowing engineers, weapons operators, and commanders to coordinate more effectively during both routine operations and high-intensity combat situations. Advanced communication systems connect the destroyer with satellites, aircraft, submarines, allied warships, and command centers across the globe, ensuring seamless coordination during multinational operations. The 2026 USS Zumwalt is also becoming increasingly important as a platform for future weapons technologies. Thanks to its enormous electrical generation capacity, defense planners view the ship as an ideal candidate for integrating directed energy weapons such as high-energy lasers and potentially electromagnetic railgun systems as they mature. These technologies could eventually provide lower-cost defenses against drones, incoming missiles, and other threats while reducing dependence on expensive interceptor missiles. Although some concepts remain under development, the Zumwalt's electrical architecture was designed years ahead of its time specifically to support these next-generation capabilities when they become operational. Survivability has been engineered into nearly every aspect of the destroyer. Critical systems are distributed throughout the ship to minimize the effects of battle damage. Advanced damage control systems automatically monitor flooding, fire, and structural integrity while assisting the crew with emergency response procedures. Reinforced compartments help contain damage, allowing the vessel to continue operating even after sustaining significant impacts. The outer hull has been designed to reduce vulnerability while maintaining excellent seakeeping performance in challenging ocean conditions. Combined with advanced electronic warfare systems capable of jamming enemy sensors and confusing incoming missiles, these defensive features make the USS Zumwalt an exceptionally resilient warship. Operational flexibility is another defining characteristic. The destroyer can perform long-range strike missions, escort aircraft carriers, defend allied ships from missile attacks, conduct anti-submarine operations, gather intelligence, support special forces, and participate in humanitarian missions when required. Its advanced sensors and communication systems make it a valuable command platform during joint military operations involving multiple branches of the armed forces. Whether operating independently or as part of a larger naval task force, the Zumwalt provides capabilities that few other surface combatants can match. Despite its remarkable technology, the Zumwalt program has faced criticism throughout its history because of its high development costs and the limited number of ships constructed. However, many of the innovations pioneered aboard the USS Zumwalt have influenced the design of newer naval vessels and continue to shape future warship development. Technologies such as integrated power systems, advanced automation, distributed launch cells, stealth architecture, and highly networked combat systems are increasingly becoming standard features in next-generation naval platforms around the world. In many ways, the Zumwalt serves not only as an operational destroyer but also as a testbed for technologies that will define naval warfare for decades to come. Looking toward the future, the 2026 USS Zumwalt DDG-1000 remains a symbol of